the joint, that's the jam. Turn that up, play it again. That's the joint, that's the jam. Turn that up, play it again. That's the joint.
Okay, here's number 1. We're going to find the general solution to this ODE, and it is a linear form, and we can check that by moving this guy over to the right side. So we have y prime is equal to negative 2t times y plus 5t. So here we can identify an a of t, right? So a of t is equal to negative 2t here, and our f of t is 5t, okay? So f of t is equal to 5t here. Alrighty, so from here, what we're going to do, I'm just going to move it back into the other form, because that's what we would normally do, is subtract this ay to the left side, and it was already in that form. I just wanted to move it over in the beginning just to find our a of t, okay? So y prime, and then we have plus 2ty is equal to 5t. So now what I'm going to do is I'm going to use the integration factor method on this one. So to do that, we need a mu of t, which is equal to, according to the formula, it's e to the negative integral of a of t dt, okay? So when we do that, our a of t, when we plug that in, we actually have negative of negative 2t dt, okay? So the negatives cancel out and they become positive. So our mu of t, our integrating factor, is equal to e to the, and the integral of 2t is simply t squared. So our integrating factor is just e to the t squared power. Okay, so once we have that, we can multiply that on both sides of our equation here. So e to the t squared, that's our integrating factor, right? So we have e to the t squared times y prime plus 2ty is equal to 5, well, I can write the other one first. E to the t squared times 5t. Okay, so now we have something like that. And then on this left side, this can consolidate into e to the t squared simply times y. And this is the first derivative of that, so prime. And then on the right side, we have this 5t times e to the t squared. And now we're just going to integrate with respect to t on both sides, integrate, and we'll continue this on the next slide. So now that we have the integral of e to the t squared times y prime, and then dt is equal to the integral of 5t e to the t squared dt. Okay, so on the left side, that's pretty simple. Those just cancel out, the integration and the differentiation going on. And then this is equal to, and this is the more tricky part, I suppose you could say. So we'll just do u substitution here. So u is equal to t squared. So du is equal to 2t dt. So if we get dt by itself, so it can do direct substitution here, then we get du over a 2t, and I don't know what markings are going on here. So there we go. So du over 2t. Okay, so when we replace that, we can't really do anything with the 5t. We don't have anything to directly replace it. We can replace the t squared with a u and the dt with du over 2t. Okay, so the t's cancel out nicely. And then we're left with, this is a 5 over 2 times the integral of e to the u du. So this becomes 5 over 2 times e to the u, and u, I'm just going to replace it with the t, okay? And then, of course, we have our plus c because we had an indefinite integral here. Alrighty, so we have e to the t squared times y is equal to 5 over 2 e to the t squared plus c. So now we're just going to divide all across the board with by e to the t squared, so we just get that y of t is equal to 5 over 2 plus c times e to the negative t squared here. Okay, and that is it. That is our general solution to the linear equation, which was our ODE.